This is the carbon dioxide sensor. It's used in several of our lab manuals. It shows up in the biology manual, the physiology manual. So it's used to measure the concentration of carbon dioxide gas. So you always want to make sure you're doing it gas. You don't ever put this into a liquid. And the way this sensor operates, it actually uses an IR detector. And so it has an infrared source that if the CO2 goes through these holes, the CO2 will absorb some of the infrared radiation from the detector, and the higher the concentration of the CO2 gas, the less infrared makes it to the detector. Now, since this is using an IR source, you do need to let it warm up for 90 seconds when you use it. So when you plug it in, at first it actually will not give you a correct reading until it's ready for collection. Another thing about that is that if you're using this outside, you would like to avoid having this in direct sunlight, because you end up warming this up and you can cause a change in how the unit's reading there. So you want to avoid that. Now, this is a dual range sensor, and so there's a sensor setting switch here, so it's a sensitivity switch. The low range is a 0 to 10,000 parts per million. A lot of the experiments will use that. And then the higher range is 0 to 100,000 parts per million. You might need to use that if you're going to breathe on it or something like that. The sensor in general doesn't need to be calibrated, but you can, to do the calibration, it's important that you put it into a known condition. Take the Nalgene bottle that comes with it, and you could collect a sample of air, and it has a lid that you can put on it, and you could bring it back in and then do the calibration that way if you wanted to. There is a calibration port right here, and you can take maybe a paper clip and press down on this until the unit stabilizes. It'll end up with a reading of 380 parts per million. Then we assume that's what it is outside in open air, and then you're good to go. To use this, we suggest that you would use it with several different chambers that we have. I just mentioned this Nalgene bottle. This is the one that comes with it. Another option is to use this Bio Chamber 250. And this allows you to put more than one sensor in if you would like. So you could put a CO2 and maybe an oxygen sensor in there, so you can use that one. In addition to that, we have the Bio Chamber 2000, and it allows us to put two sensors in a container. And so it has two holes, so we could put a CO2 sensor here, maybe an oxygen sensor there, and measure both of those two things simultaneously. Again, you might use this with labs like the respiration of peas. It's one I'm going to use here. You could use it with maybe put some crickets or worms in there and look at their respiration rate. Fermentation of yeast. So you're producing CO2 for the fermentation, you might use it that way. Some chemical reactions that generate CO2 gas. And so anything that's generating the CO2 gas, you would use this device. So now we're ready to maybe collect a little data, and we need to plug in the CO2 sensor to our LabQuest. And so I'm going to plug it in here. And so once it goes in, right now the device is reading 0 parts per million. And we said it needs to warm up, and it will continue to give us a reading like that until it is warmed up. And so that takes about 90 seconds for that to warm up. And I want to make sure that I have this on that lower range setting there. While that's warming up, what I'm going to do is take my peas, and these are some peas that I started soaking a couple of days ago. They're actually sprouting at this point, and so they're probably producing a lot of CO2. And I'm going to place them into my bottle there. There's about 25 or so peas there. And so I'll just put those there. And now, there we go. So our unit is now reading here, and so inside our room here we've got about 600 and something parts per million. So if we look at our collection parameters in the upper right corner here, we see time-based, meaning that it is a variable as a function of time, so CO2 concentration with time. The default rate is 0.25 samples per second. It's actually every 4 seconds it's going to make a measurement. It can go faster than that, but because we're measuring the CO2 that has to diffuse through these holes, it may not change all that rapidly. So collecting data faster than, say, 4 points per second, you really don't have to do that. And you end up generating maybe more data than you want to be able to do that. So you need to allow time for that CO2 to make it into the sensor there. And then if we look at our default time for this, it actually is a 600 seconds, so it's a 10-minute. And that's fine for a lot of experiments. And in fact, so for this one, we'll just use that as our default setting here. So I put my peas into my bottle, and I want to put the sensor into here. One suggestion that we have here is that you actually run the experiment on its side here. Because that CO2 gas is heavy, it tends to form a layer down towards the bottom of the container. And if you do it upright, it may take longer time for it to fuse, and you end up with kind of a layering effect there. And so once we've done this, we're ready to collect the data. And to begin collection, all we need to do is press the collect button, and we press collect, and it's now going to collect for 10 minutes, and we'll watch what happens to the concentration of the gas in the container. So we've finished our data collection, and it looks like our CO2 level was increasing nicely there. And we might want to run some analysis here. So it looks like our CO2 was increasing fairly constantly there. So why don't we run a curve fit and maybe look at something about the rate. So I'm going to go to Analyze, and I'm going to go down to where it says curve fit, and I will check the box next to CO2. And so now I need to maybe try my equation here. Looks linear to me, so I'm going to try a linear fit. And there we get our fit, and I will say OK. And it looks like it fits nicely, and we have a slope there of 4.4 parts per million per second there. So it's increasing at a constant rate. So again, this sensor is used widely for biology and biology-related experiments. It's definitely a good one to have, and it allows you to measure things that would be very difficult to do other ways.